Hello learners and welcome to the world of learning with LearnBlaze. In this video, we are going to explore the algebraic square identities which help us solve complex expressions. Without further ado, let's get started. Before actually diving into identities, let us see what variables and constants are. Okay, now what is a variable? A variable is any value that can change and is represented with alphabets and symbols. For example, the amount of electricity you use every day, or your daily weather report, or just your score on an exam. Now, what is a constant? This is a value that always stays fixed and it never changes. The most common examples of constants are numbers, or it can also be the number of days in a week or the number of sides in a square. These values do not change. Now let's see the first identity, which is the square of a binomial sum, a plus b whole square, which equals a square plus b square plus 2 times their product. We'll look at an example to understand this better. 2x plus 5y whole square. Using this identity, we can simplify this into a form which is a square plus b square plus 2 times ab. Here, 2x represents a and 5y represents b. This gives us 2 square x square plus 5 square y square plus 2 times their product. Upon further simplification, we get the final answer in the form of a square plus b square plus 2 times a into b. Now, calculating 101 square directly can be really tedious. Let's use this identity, which can also be really useful in finding the product. Now, let's split 101 in a plus b form. I can split this in many ways, but in this case, choose the two numbers wisely such that it is easier to calculate a square. Now, I will split 101 into 100 plus 1 whole square. Simplify this using the identity, which gives us 100 square plus 1 square plus 2 times their product. Upon further addition, we get the final answer, 10,201. This is much easier than direct multiplication. Here are some practice questions on this identity. Put your thinking cap on and solve this. Now, let's see the second identity, which is the square of a binomial difference, a minus b whole square, which equals a square plus b square minus 2 times their product. Let's look at an example to understand this better. 2x minus 5y whole square. Using this identity, we can simplify this into a form which is a square plus b square minus 2ab. Here, 2x represents a and 5y represents b. This gives us 2 square x square plus 5 square y square minus 2 times their product. Upon further simplification, we get the final answer, which is in the form of a square plus b square minus 2 times a into b. Again, calculating 99 square directly can be a waste of time. Let's use this identity, which is helpful in finding its square. Now, let's split 99 in a plus b form. I can split this in many different ways, but in this case, choose the two numbers such that it is very easy to calculate a square, just like earlier. Now, I will split 99 into 100 minus 1 whole square. Simplify this using the identity, which gives us 100 square plus 1 square minus 2 times their product. Upon further addition, we get the answer, 99,801. This also saves time and, most importantly, reduces the risk of making mistakes. Here are some practice questions on this identity. Give it a shot. Can you solve this one? Let's look at the third identity, which is the difference of two squares, a square minus b square, which equals a plus b multiplied by a minus b. We'll see this in action through an example, 4m square minus 9n square. We can simplify this into the form which is a plus b multiplied by a minus b. Here, 2m represents A and 3n represents B. How did we even get 2m and 3n? We should make sure the square is applied to both the constant and the variable. If the square is 4m square, then A is the square root of 4m square. The same applies to 9n square. After simplifying, this gives us 2m whole square plus 3n whole square. Upon further solving using the identity, we get the final answer in the form of a plus b multiplied by a minus b. Let's use this identity to solve 95 square minus 5 square. Now, we can directly use this identity as this is a single number. So 95 is A and 5 is B. Using this identity, we can write it now as 95 plus 5 into 95 minus 5. Let's add this further, which gives us 100 into 90, which is equal to 9,000. Here are some practice questions on this identity. Dive in and test your skills. Now here is a practice worksheet that you can do on your own using the identities discussed in this video. Feel free to pause the video and solve these questions on your own. Alright, this is it for this video on Algebraic Square Identities. Stay tuned to hear updates on new videos. What should I make next? Let me know in the comments down below. Thank you so much for watching and see you in another adventure of LearnBlaze!